come out in front. And so I'd have 1/3 the indefinite integral of u to the negative 1/2 du. When I take the indefinite integral of this, I would have 1/3 times, and again I add 1 to the exponent and divide by the new exponent, plus c. Let's see, this is 1/3, and we have here u to the 1/2 divided by 1/2, 1/2 plus negative 1/2 plus 1. Invert and multiply, so I'd have 2/3 u to the 1/2 plus c. Again, I have to rewrite this in terms of the original input. So my substitution number 2 is going to be f of x equals 2/3. I go back up and remind myself, what did u represent? It's x cubed plus 3x plus 4. So x cubed plus 3x plus 4 to the 1/2 power plus c. If I do a check on this, I would take the derivative of that value, so I'd have 2/3 times 1/2 x cubed plus 3x plus 4 to the negative 1/2 times the derivative with respect to x of x cubed plus 3x plus 4 plus 0 for the constant term. Let's see, this is 2/3 times 1/2 x cubed plus 3x plus 4 to the negative 1/2 times 3x plus 3. 2/3 times 1/2 is 1/3. X cubed plus 3x plus 4 to the negative 1/2, and I can factor out a 3 and I get x plus 1. So f of x, the derivative of that, would be x plus 1 divided by the square root of x cubed plus 3x plus 4. Is that the integrand that I started with? And it is. Okay, we're going to finish this section up with 2 application problems, and this is the first one. Find the supply function x equals f of p that satisfies this initial, in other words, the marginal supply function. So what we're asked to do is to find the integral of p times p squared minus 25 to the 1/2 power dp. Now, in order to do that, I see I have a composite function, so I'm going to go off to the side and say let u equal p squared minus 25. Then I have du dp, because I have a variable p here, as 2 times p. Multiply both sides by the differential p, so I have 2p dp. And I need to look at this and see if in fact I have exactly the same thing over here. So I'm going to rewrite this and put the value p dp together. I have it almost the same, but here I have an extra factor of 2, so I will multiply both sides by 1/2, and then I have p dp. So that is off to the side, and I'm ready for my first substitution. So substitution number 1, we'll make this the integral of, and u has the same value as p squared minus 25, so it's u to the 1/2, and the p dp has a value of 1/2 du. That's the same thing as pulling this scalar out in front and then looking at the indefinite integral of u to the 1/2 du. That's going to be 1/2, and then we go through the very same thing. We add 1 and divide by the new exponent, plus c. So I'm going to have 1/2, and then in here is going to be u to the 3/2 divided by 3/2 plus c. If I invert and multiply, I'd be multiplying by 2/3, so I end up with 1/3 u to the 3/2 plus c. Again, I cannot leave it in that form because the original problem is in an input variable of p. So I do my second substitution, and I have then, let's go back up and look how we're writing this, x equals f of p. So x equals f of p is going to be then 1/3, and let's go back up and check. U is the same as p squared minus 25. So this would be p squared minus 25 to the 3/2 plus c. Now, we are given some information. Well, we're told that x, which is the output, is 600 when the input is 13. So we're going to use then the pair of numbers where the input is p, the output is x, and we know that when the price is 13, the supply is 600, or the demand for that is 600. So we have 600 equals 1/3 of 13 squared minus 25 to the 3/2 power plus c. This is going to allow us to find the exact value of c. So we just need to look at this multiplication here. If we, let's see,